In this backup video, we are going to look at the description given in the handout and try to draw this corresponding ER diagram using Drawio. The ER diagram is already here, but in the projects, you are only given with a description, and it is a good exercise to try to draw this ER diagram on your own. And you are going to do it for the project as well. So let's start with opening Drawio with a new diagram. And in this description, let's look at, you are going to design a database for a school. So most of the time you are designing the database for some company, for some concept, etc. And in these cases, you are not storing that company or the school as a separate entity in the database. So one mistake the people could do is you are not doing it for multiple schools, not for a list of schools. It's just for a school, and this database as a whole is going to belong to the school. So the starting sentence is given us some information. In the description, some sentences could give information about the usage of the system. Not all of them talking about the data and the dependencies. And in the ER diagram, we show what we store and how it's related together. So not all of the sentences here will contribute to the ER diagram. So users of the system have unique ID number, name, surname, and password. So from here, I can understand that we need to store some users. And for each user, we need to store multiple attributes. A unique ID number, if there is the name unique in some place, that's our primary key. And for the other attributes, sometimes there could be more information. But now I know that there will be users with unique ID numbers, so primary key IDs, and other attributes called name, surname, and password. Let's do that in Drawio. I'm going to create a new triangle. So the last time I created a triangle or some shape, I made a tick. Therefore, I needed to make it 1 point. But in your example, if the file is new, then it should be the rectangle. So sorry, if I said triangle, it should be the rectangle. For the entity sets, it is going to be for the user. I'm going to resize it. So if you do not know how to resize, move items, it was discussed in the first video of Lab1. So in here we are focusing on how to translate the description into the diagram. I'm going to include an ellipse shape, write ID as my attribute name, and use the underlining. And the hotkey for underlining is Ctrl U on the keyboard. I'm going to make it smaller and include a line here to connect ID to my user entity. And I'm going to have other attributes called name. For the name, I don't need the underlining. Choose the shape and Ctrl U to remove the underlining. I'm going to duplicate the line as well. And by the way, you can also choose multiple items and Ctrl D to duplicate them together. So for name, I did that. I'm going to rename it as surname, and I only need to connect this end to the user. To select multiple items, you can click on one of the items and then click on the other items while you are holding the control key or the shift key on your keyboard. So if you are holding control or shift, they are like the same. So you can hold shift key, choose surname, and then this line that connects surname to user, and then you can leave the shift key and Control D to duplicate them. So for this one, if you look at the description, we also need the password. And then I need to connect this end to here. In the description, it says a user could be a student, a teacher, or a staff. So it can also say it like that. The user types are students, teachers, and staff members, etc. So this is talking about some types of users. But with only this information, we might also include a type to the user, a type attribute. We need more evidence to create an easy relationship. So it says that for students, system keeps track of amount of scholarship as well. So student, which is a type of user, for them I need to store an additional attribute. At this point I should decide that yes, I need the is a relationship. Otherwise it could be a simple attribute for the user as well. But reading this sentence, I know that this should be an is a relationship. I'm going to include the triangle, click on the rotation symbol a bunch of times, 3 times exactly, and write is a on top of my triangle, get it on the next line with hitting the enter key, resize it, and the user is the parent, so it should be on top. I'm going to duplicate this line and connect it to the top anchor of this triangle. I need the teacher entity set and another for the student and another for the staff. And these are the children of user, so I'm going to connect them using this bottom side of the triangle. You may use the anchors or you may directly connect them to the triangle, but be aware that then you need to keep the entity below the triangle. Otherwise, if you put it here, it is confusing, so that it is better if you connect to the bottom anchor. So then it says that a student can enroll to many courses and a course can have many students enrolled. I was not aware of this course entity yet, so sometimes you might get the description about the relations first. So this can appear at any part, maybe at the beginning, and from here a student can enroll to many courses and a course can have many students enrolled. We are describing a relationship between two different things, but those two different things, what are them? So students we already know, but for the courses the description is further down. So for each course we keep a unique course code, course name, and an optional description. So we should read the whole text first and then start with the entity sets for a better approach. Otherwise it might be confusing. So from this sentence I know that I should have an entity set for courses, and for each course I have this course code primary key and the course name and then description. It says an optional description. For now in the ER diagram we are only showing what we can store. Okay, we have a field to store the course code, the course name, and the description. But whether the description is required or optional, we cannot show it in the ER diagram. But further, in a further point in the database system, we can actually set this feature. So for now, I'm going to create a new entity sets course, and in here I need the course code. Let's resize this attribute. I need the course name and the description. And all these attributes should be connected to the course with simple lines. I'm duplicating the lines and getting one end on the attribute and the other on the entity set. And I can return back to this text here. A student can enroll to many courses and a course can have many students enrolled. So this is some sort of relation between the student and the course. So let's create this diamond shape, and the course is going to have the students and students will be enrolled to courses, so you can read it in different ways, but let's name it as enroll. Let's carry these things around to have them closer to the student entity, because this is going to be between these things, these entities. Let's first start with simple lines. But I know that to tell more about the relationship, we can have additional constraints for participation and cardinality. Participation is whether all of the attributes in an entity set appear in the relation or not, and the cardinality is about one-to-one, many-to-many, and one-to-many relationships. And in here, the information says that one student can enroll to many courses, and a course can have many students. So it can say that multiple, it can say that more than one, etc., more than zero. So these are giving information about the cardinality. And with some of them, it can also give information about the participation. If it was saying a student can enroll to, or let's say it like that, a student should enroll to more than one courses. If it was saying like that, we would understand that on the student side, we should have total participation, because it is saying that a student must enroll more than one courses, and it should be without an arrow to allow enrolling to many courses. But for now, it doesn't give information about the total participation, right? It is not saying that every student should enroll to the courses. It is only saying that, okay, a student can enroll, but may not enroll to a course as well. It is only giving information about the cardinality with this many and many keywords, let's say, that we capture from the description. So we should have simple lines indicating the many-to-many relationship. A grade between 0 and 100 should be stored for each enrolled course. So a student is enrolled to the course, and we should also store this grade somewhere. And if you remember, if it is not belonging to the student and not to the course, but it should belong to this relationship between the student and course, then we include the attribute to the relationship. So I need another attribute called grade, and I will link this to the relation enroll, because this is the grade for this student taking that course. This grade does not belong to the student only and not to the course only. It belongs to the relation between a student and a course. And it also says that this grade should be between a range, in this range. But now in the ER diagram, we are not showing the limits of the data. So again, this is going to be used in a further point. Every course must be taught by exactly one teacher. On the other hand, a teacher could teach many courses. So again, this describes a relation. We understand that because it uses two different entities that we have. We have course entity and a teacher entity, and it is describing some relation between them. And it says that every course must be taught. Okay, we understand that there should be total participation on the course side, because there should not be any courses in the corner that are not taught. Every course must be taught, and by exactly one teacher. So there cannot be multiple teachers in this description. There cannot be multiple teachers teaching the same course. There can only be one teacher. On the other hand, a teacher could teach many courses. So for a teacher, there could be many courses related. So let's come here. We are going to create a relation between the teacher and the course. I'm going to duplicate this enroll and turn it into teach, for example. And we always start with simple lines, and then we should integrate the further information. So there is some, oh, by the way, if you click on an item, there are also some arrows appearing, and if you click on this arrow, you have the option to create further shapes that are connected to the original shape. In this case, we are not going to use them because they're not useful in the case of creating ER diagrams. If you also like hold this and carry it around, it creates a line but with an arrow, so you might like confuse it. It is harder to like create the line first, then get rid of the arrows, etc. Therefore we create the lines individually, and once you have just one line, you can like use it to connect existing items together. So that was what while I was trying to carry this line, I mistakenly clicked on this arrow next to the teacher. That's why you saw this additional line. So okay, I have my relation, but if you look at the information was indicating that each course should be taught by exactly one teacher. So each course should be taught. This is the total participation on the course site, and it is further saying that each course should be taught by exactly one teacher. There cannot be many teachers for a course. So for each course there will be only one teacher, but for a teacher there could be many courses. If you remember our dog example, in that example dogs were multiple, like the same owner can have multiple dogs. In this case, the same teacher can have multiple courses. That's why we are going to have an arrow on this course site. So I will choose this line and choose the arrow. If we continue, every student should have one teacher as their advisor. A teacher may be the advisor of many students. Again, a similar relationship, like teach, this time between a teacher and a student. And you see that as we are designing the diagram, sometimes we need to shift elements around. In that case, you can also choose multiple elements and carry them around. And this is why using a tool to draw your ER diagram is very helpful. Otherwise, if you were trying to do it on the page, on a paper, then it is hard to find the best position for each of your elements. So now we have a relation between teacher and student, this time the advisor relationship, and it follows a similar structure. Every student should have one teacher as their advisor. So this advisor relationship, the student is going to have total participation indicated with this tick line, and for every student there should be one teacher, but for a teacher there could be many advised students. If the arrow was reversed, we can right click and choose reverse, but the end that we choose, the starting point, was the correct one. Sometimes we might like have the lines reversed, and in that cases, when you include the triangle, you might either like choose none here and choose the arrow on the other side, so these are representing the starting and the ending points of the lines, or just include the triangle on one side, the arrow on one side, and then right click and reverse it if it is not correct. So a teacher could have many addresses stored in the system, but an address could belong to only one teacher. Each address has a unique phone number, a city name, and a street name. It also says that if there is an address stored in the system, it should belong to a teacher. So we are going to store some addresses in the system. And for each address, as a unique identifier, we are using the phone number, and we are also storing the city name and a street number. So let's create it for now. So we are going to have an address entity, and we should have some relation between the teachers and addresses. Let's say belongs, something like that. I'm going to first create it with simple lines. And for an address, I need to store three different things: phone number, city name, and street number. So let's get an attribute, phone number, city name, and the street number. And if you think that to find a unique building, actually we need more, right? In the same street and in the same city, we have multiple different buildings actually. For now, let's make the phone number the primary key. It was saying that each address, a teacher could have many addresses, but an address could belong to only one teacher. So in this case, dogs are the addresses, right? On the address side, I need an arrow. So I will include the arrow. It's on the wrong side. Click on the line and then reverse it. So for a teacher, there could be many addresses, but each address should belong to only one teacher. But with some assumptions, we can make it into a weak entity as well. If you look, it is also saying that if there is an address stored in the system, it should belong to a teacher. So I understand that there should be total participation on the address side. So you might find it familiar with weak entities as well. We had this total participation and this kind of one-to-many relationship. And if we make some assumptions, we can turn it into a weak entity as well. So let's assume that each address can only be identified with the teacher it belongs. So it is not written in the description. I'm going to assume that we somehow need the teacher's ID, teacher's primary key as well, to be able to find a unique address. To make a weak entity example in the given ER diagram as well, it is like this. And based on the description, you might not make it a weak entity. So there is no explicit definition saying that this should be the weak entity. But I can make some assumptions and adjust my database accordingly. This time I'm making an assumption. So in the project, if you are making such assumptions, we expect you to include a txt with your upload saying us about those kind of assumptions. But I can just leave it as this as well. But to show an example of a weak entity, I'm going to make the address and this relation belongs. So this is the weak entity, this is the weak relation, and therefore the primary key is no longer the primary key. So I'm going to get rid of the underline and add a dashed line underneath the phone to say that, okay, there could be multiple phone numbers, multiple same, or say it like this, there could be duplicate phone numbers in the address list. There could be multiple entries with the same phone number. But let's say in those cases, in the same building, there are different teachers. But that building is, let's say, using the same phone number, maybe in the same family, etc. There could be multiple teachers. And then to be able to choose that unique address, I also need the phone number and the teacher that this phone number belongs to. So let's say it like this. Whenever I get a phone number, I want to find the teacher that this phone number belongs to. If I only have the phone number and this phone number is the phone number of the building, and if in that building there are multiple teachers in the same family, for example, then I cannot find a unique teacher. However, in the description it was saying that uh, each address, a teacher could have many addresses, but an address could belong to only one teacher. It is saying this. But in this case, we are kind of contradicting, right? We are saying that, okay, this address, but the same teachers are using these address. Then to be like more correct, I say that address is a weak entity, and then to identify a unique address, I'm using the phone number as well as the primary key of teacher, which is the ID of user. The ID of user is inherited to the teacher. Therefore, in the teacher, I assume that I have the ID. And to find a unique address, I need the phone number plus the ID. But you can make different assumptions. You can say that, okay, I am using the cell phone numbers. Therefore, for each different teacher, the phone number is going to be different. And then you may not need the weak entity. So to make a weak entity example, we use this assumption. Otherwise, it might not be always existing in your project descriptions. So each student can have at most one locker, and each locker could belong to at most one student. So from here, we did not introduce the locker entity yet, but we know that with students there are some relation with lockers. And a locker is identified by both its floor number and locker number. So lockers, we have lockers that we give to the students, and to identify a unique locker, we use the floor number and the locker number. Let's create such entity first, locker, and this is going to have the locker number plus the floor number. And to identify a unique locker, I need both of them. It is going to be a composite primary key, so I need to underline both the floor number and the locker number. And the students are going to have these lockers, so I need a relation between the student and the locker entity. And let's name it, for example, have. Students have the locker. It says that for each student there can be at most one locker, and for each locker there can be at most one student. So when we say at most, it says that there can be 0 or 1. If it was saying exactly, then it says one locker, exactly one locker. But in this case, some students does not have lockers, some of them have, and some lockers does not have any students, but some lockers have. So there are some unused lockers and some students without lockers, and also some students with exactly one locker. So I understand that this is a one-to-one relationship. Therefore, for the lines, I need these arrows, and remember, the arrows should be always next to the relationship. Therefore, if it is not correct, I right-click on the line and correct it by reversing. This is a one-to-one relationship. If it was saying that every student should have exactly one locker, then I might need the total participation on the student side. If it was saying that every locker should be used, then I need the total participation on the locker side, which we show by the ticker lines. So it says that sometimes a padlock can be given to a student for his or her locker. In this case, the system should keep track of which staff gives which locker's key to which student on which date. So the students might have lockers, and in this case, sometimes for some of the students, we also give locks for security, etc. Maybe that student is putting some important thing in that locker, so we need the padlock. And the padlocks are not like randomly appearing. The staff members are giving the padlocks. So if some problem occurs, we might also need the information about the staff member who is giving this locker to this student for that locker. And we also need this date. We should also store this date of the staff giving this lock. In this case, we are saying that, okay, some students does not have lockers. Some lockers do not belong to students. We are going to give padlocks to only the students that have lockers. So that's our requirement, right? A locker is okay, that one. Sometimes a padlock can be given to a student for his or her locker. So we are not giving the padlock directly to the student. We are giving it for the locker to the student. And then we need to be including the have relationship for this padlock. So it is going to be an aggregate relationship in this case. So I'm going to carry the stuff further. You might use it like this. I will create a new rectangle, decrease the line width, send it to back to include the relationship have. So this line is incorrect. So where did that come? Okay. I'm using the undo button, Ctrl Z. Since I carried it to the line incorrectly, it positioned this item in between those lines. So what I should have done was to make it larger, send it to back without dropping it on the line. So now I have the rectangle behind my items. And if you position it better, you might have something like this. This should be a dashed rectangle to indicate the aggregate relationship. I will choose the rectangle. Under the style menu, I have line options. I will have the dashed rectangle. In here, then I need to give padlocks by staff members to this aggregate relation. So I'm giving to the relation have actually, but I cannot connect relations to the relations directly. Therefore, I'm using an aggregate relationship. So the staff member is giving padlock. So on one side, I connect to the staff member. On the other side, I'm giving this padlock for a student that has locker. If I give it to the student directly, then I might allow giving padlocks to the students that does not have any locker. If I give it for the locker, I might give padlocks to the lockers that do not belong to anyone. To make sure that I am giving the padlock for the correct reason, I define this give padlock relation on top of this have relation. So now I cannot do mistake, right? When I give a padlock, there should always be the students and the locker related with the have relation. Based on that relation, I'm giving the padlock. And I also need to store this additional date information, this time again within the relation give padlock. So when we go into the database in the upcoming labs, this relation, remember, for every entity set, I should have a primary key. It could be a composite file, but there should be some primary key. For relations as well, when we go into the implementation, we are going to have some primary keys. So when we go into LibreOffice Base, entity sets are going to become tables, but relationships are also going to be tables. We are going to use tables for both of them. And we are going to make a logical difference between them based on how we use them. But for every table, there should be some primary key to find a unique row in it. And for relationships, the primary key is the primary key of the entity sets that are connected to that relation mostly. But based on the one-to-one relationships and many-to-many relationships, the primary keys could differ. But in this case, let's say in the have relationship, I'm keeping the information about which student and which locker is associated. So in the have relationship, I'm going to have a list of items, and for each item I need to store the student's primary key, which is ID, and I also need to store the locker's primary key, which is floor number plus locker number. So inside the table that I store for have, I'm going to have ID, floor number, and locker number. And similarly for give padlock relationship, I'm going to store the ID of the staff plus the primary key of have, which we talked just before. It is the ID of student plus floor number of locker plus the locker number of locker. So in this relationship, we are going to be needing multiple primary keys, a composite primary key. So we made this example. You can arrange it similarly to have the same picture, but more or less based on the description, that's how we find, or that's how we make the ER diagram. Then to save this diagram, I can go through File and Save, and whatever option I choose at the beginning, it's going to either save it to my drive or to my PC. I can save it as a different file as well. And let's like close this one, and going through open existing diagram, you can choose some file from your desktop, etc., to open that file. So we expect your ER diagrams to have this .draw.io extension. If you install the desktop version, you can also like open these files when you are not online.